Lately, the buzz around AI agents and agentic AI.
Oh, absolutely.
No, exactly. I mean, look at the Google Trends data. We've got figure one showing this.
Right around November 2022.
Okay, what's really going on here? What's behind this, spike?
Well, what's really fascinating is that this feels like more than just another tech buzzword cycle.
Hmm.
This surge seems to signal a pretty fundamental shift in how we're even thinking about AI.
How so?
We're moving from, let's say, AI as just isolated algorithms towards thinking about more autonomous, interactive, even collaborative intelligent entities.
Which raises the big, how's that going to reshape, well, everything digital?
Exactly.
And that's precisely the deep dive we're taking today. Get a clear understanding of the difference, AI agents versus agentic AI. And we've got some solid ground to stand on. We're using this really in-depth review paper, AI agents versus agentic AI, the conceptual taxonomy, applications, and challenges.
It's a great resource.
That gives us definitions, applications, challenges, sort of a roadmap for this whole area.
And that clarity is crucial because these terms get thrown around a lot, sometimes interchangeably.
Which just creates confusion.
So our mission here is to give you, the listener, a really clear picture of what each term means, their capabilities, and importantly, what really sets them apart.
Okay, let's jump in. When we hear that term, what's the core idea we should grasp?
Okay, so at their heart, AI agents are basically autonomous software entities
Autonomous software.
designed for very specific, goal-oriented tasks. And they operate within digital environments. Think of them like focused digital assistants.
Okay, focused digital assistants. So it's more than just a script running. What makes them agents? The paper highlights three things: autonomy, task specificity, and reactivity adaptation.
Exactly.
Let's take autonomy first. What does that really mean in practice?
Autonomy here means once you set it up, deploy it, the AI agent can pretty much operate on its own. Minimal ongoing human handholding. It takes in information, reasons about it, and then acts to achieve its goal. That's how you get things like customer support bots handling tons of queries at once without a human for every single one.
So it has its job. You tell it what the job is, and it gets on with it.
Hmm.
These aren't aiming to be like general AI.
No, not at all. That task specificity is really defining. AI agents are built for narrow, clearly defined jobs.
Like what?
Things like sorting your email, managing calendar appointments, maybe answering FAQs on a website.
And that focus allows them to be really good at that one thing.
Exactly. Highly optimized for performance in that specific area.
Makes sense.
Mm-hmm.
Okay, and the third bit, reactivity and adaptation.
They can respond to changes happening around them in their digital space,
Like a new email coming in.
or a response from another system, an API maybe, or just changes in the data they're working with. And the adaptation part means some can actually learn a bit,
Learn.
refine their behavior over time based on feedback or new data they encounter. It's not about becoming generally smarter, but getting better at their specific job.
Now, the paper really stresses the role of foundational models,
Mm.
LLMs like GPT-4, PaLM, and these LIMS, language and image models. How do they act as the brains and eyes for these agents?
Think of these models as the engines. The LLMs give the agent language skills, understanding, generating text, reasoning, planning, and the LIMS add vision. They let the agent see and interpret images. Combine those, and the agent can interact with the digital world in a much richer way.
The paper uses this really cool example, an AI agent drone inspecting an orchard. How do the language and vision models work together?
Okay, this is where it gets really interesting. Picture the drone flying over the trees, cameras on. The limb processes the video feed, maybe identifying individual fruits, checking leaf health. Let's say it spots some diseased apples.
Yeah.
Then the LLM part kicks in. It reasons, okay, detected disease,
Hmm.
what's the right action? It could autonomously tag the GPS coordinates for a human worker,
Or maybe trigger something else.
or even trigger a more automated response, depending on the setup. It moves beyond just seeing to actually doing something intelligent about it.
So these AI agents, what's the key functional leap?
The critical difference is that autonomy and goal-directed behavior. Generative AI, like ChatGPT, mostly reacts. You give it a prompt, it gives you text or an image back. It doesn't have its own goals it's trying to achieve independently.
Right, it waits for me to tell it what to do next.
Exactly. AI agents are designed with specific objectives, interact with their environment, proactively take steps to reach that goal without you prompting them constantly.
So ChatGPT might draft an email if I ask.
But an AI agent could be tasked with schedule this meeting, and it would go check calendars, find a time, send the invites.
It's moving from creating stuff to actually doing stuff. And the LLMs are really powering this.
Absolutely. LLMs are becoming the planning and decision-making core. They figure out the how for the agent's task, and they orchestrate interactions using what the paper calls tool use capabilities.
Which brings us neatly to tool-augmented AI agents. This feels like where the rubber meets the road, turning theory into practice. What does tool-augmented actually mean?
It means the agent isn't limited to just its own internal knowledge or capabilities.
Like what kind of tools?
APIs, ways to talk to other software external databases, computational platforms, web search engines, you name it. It lets them interact with the live, dynamic, digital world.
Okay. The paper mentions two key processes here. How does the agent actually use a tool?
So tool invocation happens when the agent's LLM decides it needs external help for a subtask. It then generates a structured call, maybe in JSON format or even Python code, that tells the external tool exactly what information or action it needs.
Integration is getting the answer back.
Precisely. The tool does its thing, sends back the result. That result is then fed back into the LLM's context.
So it updates its understanding.
Exactly. The agent uses that new info to continue reasoning, decide the next step towards its main goal. The React framework reasoning and acting is a good example of this loop. Think, act, use a tool, observe the result.
That makes a lot of sense. So it's not stuck with potentially old internal data. It can get real-time info. GPT doing market analysis. How does that work with tools?
AutoGPT could use a web search tool to find competitor info, maybe a data extraction tool to pull numbers from websites, a calculation tool to analyze trends, and finally, a report generation tool. It automates that whole research workflow.
What about GPT engineer developing software? That sounds even more complex.
A GPT engineer uses the LLM for the design part based on what the user wants, but then it uses tools to actually write the code, run it locally, test it, find bugs, and then iterate on the code based on those test results. It's a more complete autonomous development cycle.
And paper QA querying academic databases. Huge for researchers, I imagine.
Instead of manually searching PubMed or Arciv, Paper QA can use tools to query those databases directly based on a research question, pull relevant papers, and then use its LLM to synthesize the findings and answer the question grounded in that literature.
Figure 6 in the paper shows this visually too, right? An agent doing a news search answering a query.
Exactly. It shows that whole flow. Perceive the request, reason about needing news, act by using a search tool, and finally generate the answer, all coordinated.
Okay, AI agents, very capable for specific tasks. But then there's agentic AI. The paper calls this a conceptual leap. What's so different? Why the leap?
The big shift with agentic AI is moving beyond just one agent working alone. It's about systems of multiple intelligent agents coordinating and collaborating.
Multiple agents, like a team.
Exactly. Think of it as moving from a single smart worker to building an entire intelligent team to tackle bigger, more complex problems.
The paper mentions things like goal decomposition, multi-step reasoning across agents, communication between them, shared memory.
So faced with a complex goal, an agentic AI system can break it down into smaller pieces. These pieces, or subtasks, get assigned to different specialized agents. These agents can then reason, plan over multiple steps, and critically talk to each other. They share information and maintain a common understanding, maybe through some kind of shared memory or knowledge base.
The paper uses a smart home analogy in Figure 7 to make this clear.
Sure. So on one side, imagine a single smart thermostat. That's like your AI agent.
Okay, specific job.
Okay.
Control temperature.
It works pretty much on its own. Now, contrast that with a full smart home system that's the agentic AI analogy.
Multiple devices.
Multiple agents. Maybe one for weather forecasts, one managing schedules, one for energy use, one for security. They share data like, is anyone home? What's the outside temperature? And coordinate their actions.
To achieve bigger goals.
Exactly. Goals like optimizing overall comfort, saving energy, enhancing security. It's that interconnectedness and collaborative problem solving that defines agentic AI.
That smart home example really helps nail the difference. It's not just more AI. It's AI that works together intelligently. In Table 1, what stands out there?
Yeah, Table I is useful. It highlights that agentic AI involves multiple agents tackling complex goals versus AI agents typically on single specific tasks. Agentic AI generally needs a higher degree of autonomy to manage these multi-step collaborative workflows. Fundamental AI agents are more independent.
In learning.
Potentially broader learning in agentic AI. This AI agents for things like chatbots, agentic AI for complex stuff like supply chain optimization or managing virtual projects.
And there are even more detailed taxonomies in Tables 2 and 3 mentioning generative agents as maybe a hybrid type.
Those tables get more granular, looking at dimensions like how goals are set, how flexible they are. memory, learning, coordination strategies. Generative agents might be seen as agents focused on creation, but they could be part of a larger agentic AI system, contributing their specialty to the team effort. It shows it's maybe more of a spectrum.
Then the paper talks about the architectural evolution from AI agents to agentic AI, referencing Figure 8.
Figure 8 shows that progression nicely. You start with the basics of an AI agent: perception, reasoning, action. Agentic AI builds on that with key additions. First, an ensemble of specialized agents. Different agents for different roles: a planner, a summarizer, a data retriever.
Like building a team.
Exactly. MetaGPT does this, modeling agents like company roles. Then you need more advanced reasoning and planning methods used across these agents: React, chain of thought, tree of thoughts.
Okay, smarter thinking.
And persistent memory becomes crucial. Ways for agents to remember past interactions, share knowledge over time.
So everyone stays on the same page.
Right. And finally, you often need an orchestration layer or maybe a meta agent. Think of it like a project manager or coordinator making sure everyone works together smoothly. ChatDev has a virtual CEO concept.
It really is like building and managing an intelligent team.
Mm.
Okay, let's talk real-world applications. We've got a good sense of the concepts, starting with AI agents, Figure 9, Figure 10, customer support automation, internal search. We've probably all bumped into these.
Those website chatbots or the search bar in your company's intranet use agents for this.
How do they work?
They understand your question, query relevant databases or FAQs, and give you an answer. They're really changing expectations for instant support.
And email filtering, prioritization, sounds like a lifesaver.
Definitely. Agents in Outlook or Superhuman analyze email content, figure out what's urgent, what needs action, maybe even suggest replies. It's smarter than just keyword filters. It gets the context.
Personalized recommendations, Amazon, YouTube, Spotify, and now in business tools like Tableau Pulse.
Yep. Agents analyze your behavior to suggest things you might like. In BI tools like Power BI Copilot, you can ask questions in plain English. Show sales trends for Q3. And the agent figures out the query, generates the chart, even summarizes it, makes data analysis way more accessible.
And autonomous scheduling assistants. Reclaim AI.
Yeah, these are getting common. They hook into your calendar, figure out meeting times that work for everyone, send invites. You just say, find 30 minutes with Sarah next week. Saves a ton of admin hassle.
Okay, so AI agents are definitely making inroads. Now for agentic AI applications, Figure 9, Figure 11, these sound more ambitious. Multi-agent research assistants like AutoGen, Crew AI.
You can set up systems where different agents collaborate on research. One finds papers, another summarizes, a third synthesizes, maybe a fourth handles formatting. They work together, orchestrated to draft something complex, like a grant proposal.
Wow, and intelligent robotics coordination.
Absolutely. Think warehouses with lots of robots coordinating pick and pack operations, or drone swarms for agriculture or inspection. Our orchard example could have mapping drones, picking bots, transport bots, all working together, sharing data, optimizing the harvest in real time.
Collaborative medical decision support sounds potentially transformative.
Huge potential. Imagine agents specializing in analyzing scans, retrieving patient history, suggesting treatments based on latest guidelines, all working together, presenting a synthesized view to the doctor. The ICU example shows how this could help in critical, complex situations by considering more factors quickly.
Games and business.
Yeah, in games like AI Dungeon, you get NPCs that act more independently and interact in surprising ways. In business, systems like Multion or Cognosis use agent teams for complex workflows, maybe cybersecurity response. One agent classifies the alert, another analyzes logs, a third suggests containment, coordinating the whole response.
Tables X and XI in the paper even list specific models from the last couple of years.
Those tables show the variety of agent types and the sheer breadth of applications emerging for both single AI agents and these newer agentic AI systems.
Okay, amazing potential. But we have to talk challenges. The paper is quite clear about the limitations. Let's start with AI agents, Figure 12A, first big one. Lack of causal understanding. What's that mean, practically?
It's a really deep issue. They're great at finding patterns, correlations in data, like hospital visits correlate with illness, but they don't truly understand that the illness causes the visit. It's just a pattern. This lack of grasping cause and effect can lead to weird reasoning or bad decisions, especially in new situations or when an action's consequences matter.
And they also inherit problems from the LLMs they use. Hallucinations, prompt sensitivity.
Exactly. All those LLM quirks carry over. Generating plausible but wrong info hallucinations, being really sensitive to how you phrase a request. Plus, often shallow reasoning, high compute costs, static knowledge after training, and potential biases from the training data.
The paper also says incomplete agentic properties, meaning they aren't fully agent-like yet.
Yeah, it's a fair point. They show autonomy for their task, but maybe lack true proactivity deciding what to do without being told. It can be limited, and complex social skills or nuanced communication needed for real collaboration.
They struggle with complex, multi-step tasks or bouncing back from errors.
Planning far ahead is hard when you don't have a deep model of time and consequence. If something unexpected happens, they might not recover gracefully or adapt well.
Okay, challenges for AI agents. Now, agentic AI figure 12b. The lack of causal understanding gets worse with multiple agents.
Precisely. When agents influence each other, that lack of causal grasp in each one can lead to weird dynamics. One agent's action might unexpectedly change things for another. That's inter-agent distributional shift. And errors can cascade. One agent messes up and it ripples through the whole system.
And just getting them to work together, communication and coordination bottlenecks.
It's a huge research area. How do you make sure they all understand the goal the same way? How do they communicate efficiently without misunderstanding? How do you manage resources if multiple agents need the same tool at once? It's complex.
Then there's emergent behavior and predictability, unexpected outcomes from all these interactions.
Sometimes emergence is good novel solutions, but sometimes it's not. Unintended consequences, system instability, makes it risky for critical applications where predictability is paramount.
And as they get bigger, scalability and debugging complexity must skyrocket.
Trying to figure out why a system of many interacting, often opaque agents did something, nightmare to debug, and just adding more agents doesn't automatically make it better. It can bog things down if not designed well.
Hard to trust what you can't understand or verify.
Absolutely critical, especially with distributed decision-making. Figuring out why something happened or who's responsible is tough. We lack good tools to formally verify these multi-agent systems are safe and reliable.
Plus, security and adversarial risks.
Potentially, yes, compromise one agent and it might mislead or disrupt the whole network.
And wrapping up the major ethical and governance challenges. If an agent team messes up,
That accountability gap is huge. If a decision made by multiple autonomous agents causes harm, who's liable? Plus, amplifying bias across agents, ensuring the whole system aligns with human values, massive governance questions.
and fundamentally, the paper says the foundations are immature.
That's the reality. Big problems like robust causal reasoning across agents are still unsolved. Moving from lab demos to reliable general-purpose agentic AI needs more breakthroughs.
Okay, lots of challenges. But it's not all doom and gloom. The paper outlines potential solutions and the future roadmap, figures 13 and 14. Let's look at some positives. RAG, retrieval augmented generation, seems key for both types.
Yes, RAG is huge. Grounding agent reasoning in external up-to-date knowledge helps fight hallucinations, improves accuracy. For agentic AI, it's also a way to create shared knowledge bases that agents can all access.
Letting agents use tools makes them more practical and allows for specialization.
Connecting to APIs, databases, code execution that lets agents actually do things in the world. Essential for single agents and allows specialization in multi-agent teams.
The Agentic Loop Reason, Act, Observe feels fundamental for smart behavior.
Absolutely. That iterative cycle, like in React, lets agents think, try something, see what happens, and adjust. Crucial for effective goal seeking and adapting to dynamic situations.
Memory architecture is vital for learning and coordination.
Yes. Different memory types: episodic for past events, semantic for facts, vector for finding similar info, let agents learn over time, maintain context for long plans, and communicate effectively in teams by sharing relevant history.
And for agentic AI specifically, multi-agent orchestration with role specialization seems the way to manage the complexity.
Break down the big task, assign roles to specialized agents, and have a coordinator manage the workflow communication. Makes it more scalable, easier to understand, and potentially more robust if one part fails.
Reflexive and self-critique mechanisms, agents checking their own work.
Building in quality control. Agents evaluating outputs their own or their peers can catch errors early, improving overall reliability and trustworthiness.
And moving towards programmatic prompt engineering pipelines.
Automating prompt creation based on task, role, context that promises more consistency and reliability than fiddling with prompts by hand for every situation.
Tackling the core problem.
These are key research directions. Giving agents causal reasoning skills moves beyond just pattern matching, and letting agent teams simulate strategies in a safe environment before acting in the real world.
And finally, building trust through monitoring, auditing, explainability pipelines, and governance.
Essential for deployment. We need to see what they're doing, monitoring, explainability, and building rules and accountability structures from the start. Governance.
Looking ahead, the paper sees AI agents becoming more proactive, better tool users, gaining causal reasoning.
That's the trajectory. Agents that anticipate needs, use a vast array of tools, understand consequences, learn continuously, and are fundamentally built for trust and safety.
And for agentic AI, scaling up collaboration, better orchestration, shared memory, simulation planning, and a big focus on ethics and domain specialization.
Building larger, more capable teams, unified ways to manage them, persistent shared understanding, strategic planning using simulation, strong ethical frameworks, and systems tailored for specific complex domains like law or science.
So pulling it all together, the big takeaway is AI agents and agentic AI both build on recent AI progress, but they're distinct paths forward. Agentic AI is the leap towards collaborative systems, multiple agents coordinating to tackle complex high-level goals.
That sums it up well. Both have incredible potential, but as we've laid out, there are significant hurdles, technical, conceptual, ethical, to overcome for reliable, safe, beneficial deployment.
And the research is pushing hard on those fronts.
Absolutely.
So for you, our listener, as you think about this, consider where these different approaches might fit. Is it the focused power of an AI agent or the collaborative potential of agentic AI that resonates more with your interests or your work? Understanding these distinctions is really key to following where it's all headed. Thanks for joining us for this deep dive.